Okay, so I'm going to go through the solutions with you. Question 1A is a transformation type of question, and the type that we're looking at is reflection in the line y equal to x. So the line y equal to x, if you think of the coordinates x, y, it's where they're equal, where y is equal to x. So you'd have things like 0, 0, 1, 1, 2, 2, 4, 4, -3, -3. Basically, where the coordinate x value and y value are the same. So if you plotted those, you'll end up with a diagonal line like that. You can use tracing paper for this kind of question, but basically, from that point, I've got to go 2 down, I've got to go 3 across, for that 3 there, and then it joins up nicely. Obviously, with a question like that, you can use tracing paper as well to check your answer. For question 1B, again, it's a transformation, but it's a translation in the vector -5, -4. Now, the -5 means 5 left, or in that direction, and the -4 means 4 down. So if we start with this top point A, I'm going to count 5 to the left, 1, 2, 3, 4, 5, 4 down, 1, 2, 3, 4. That's my point A dashed. If I label this B, then I'm going to count from B 5. So 1, 2, 3, 4, 5, 4 down, 1, 2, 3, 4 down. So that's B dashed. And the last one, if that's C, count 1, 2, 3, 4, 5, 1, 2, 3, 4 down. So that's C dashed. And it doesn't come as any surprise that you've ended up with a triangle, which looks the same in the same direction, but in a different place. And that's what we mean by a translation. It's like when you're sliding it around the grid. Okay, so question 2 is to do with the nth term of a sequence, which is given by n squared plus 7. Write down the first 3 terms of this sequence. Okay, so basically, the first term is when n is 1. So when n is 1, you're going to have n squared plus 7, which is the function. So it's going to be 1 squared plus 7. 1 squared is 1 plus 7 is 8. For the second term, that's when n is 2. So basically, you're going to have n squared plus 7, which is 2 squared plus 7. 2 squared is 4, add on 7 is 11. And the third term is when n is 3. So it's n squared plus 7, 3 squared plus 7. 3 squared is 9 and 7 is 16. So those are your 3 answers. Question 3, a multi-choice one. Circle the correct answer for each of the following. Okay, now what you've got to remember, this is what we need to work out. Okay, when the base values are the same and you're multiplying, you just add the powers. Okay, these base numbers have got to be the same. And if you're multiplying, you're going to add the powers. So you're going to do x to the 3 plus 6, which is x to the 9, which is that one there. For question 3b, we've got to simplify this, okay? Because at the moment, it doesn't look anything like the options in the answers. So let's have a look what happens when we remove the brackets. Okay, so you'll have the 7x minus 5y minus 3x. But this is where you've got to be careful, because the minus there and the positive there will give you minus 2y. Okay, then we've got to simplify. So sometimes it's easier to reorder. If you think of every term with the sign before it, okay, what I'm going to do is swap things around. So I'm going to have the 7x minus the 3x. Okay, so I've dealt with those two. And what's left? Minus 5y minus 2y. So the final answer, 7x minus 3x is 4x. And then minus 5y minus 2y is minus 7y. Okay, so the answer you want is this one there. Okay, so for question 3C, a car travels X miles in 30 minutes. The average speed in miles per hour is, okay, so because I can see average speed, the first thing I would want to do is that triangle, the one with speed, distance, time, and it's always a case of what do I know? So what do I know? X miles, so I know the distance is X miles, and I know the time is 30 minutes. But be mindful that they want it in miles per hour. So I would change that to 0.5 of an hour, okay? So if I'm working out the speed, which is distance over time, I'm going to have the distance, which is X miles over the time, which is 0.5 of an hour. But I haven't got those. I haven't got that answer in any of my options. So what you've got to realise is that that is the same as X over half, and X divided by a half is the same. Remember the rules of dividing fractions. X times 2 over 1, which will be 2x, which is the correct answer. Okay, question 4, trial and improvement. Okay, so a solution for this polynomial, because it's got a cube power in it, is between 2 and 3. So the first thing you must do is try x to be 2. So that means 2 times 2 cubed minus 3 times 2 minus 17. And you get the answer of minus 7. When x equals 3, so you must do these first. You'll have 2 lots of 3 cubed minus 3 lots of 3 minus 17. The answer to that is 28. Okay? And because 0 is between minus 7 and 28, that's what you would expect if there is a solution, that the sign would change. There'd be a minus before it and a positive after it. And the next one you do, when you do 2.5, you'll end up with 6.75. When you do 2.4, 3.448. So we're getting nearer to 0 when x is 2.3, you'll end up with 0.434. X equal to 2.2. You'll end up with minus 2.304. So you've got a positive there and a negative there. So the solution is between 2.2 and 2.3. So if I just do 2.25, which is the midpoint, I get minus 0.96875. Okay, so just to summarize, it's between 2.25 and 2.3. Okay, they're the nearest ones to naught. That one gives you that value, and the 2.3 gives you the 0.434. But round it to one decimal place, the answer must be 2.3. Okay, question 5a, the question with the graph. It tells you it's a straight line, minus 3 to 3 on the x-axis. Okay, write down the gradient of the above line. Well, for this, there's a really, really nice right angle triangle there. So that's the one I'm going to use. Okay, so in order to work out the gradient, you need the y value and you need the x value. And if you get a bit confused with that, that's your x-axis, so you can use that as a guide, and that's your y-axis for your vertical measurement. So the gradient is y over x. Y is between 0 and 4, which is 4. This is between minus 2 and 0, which is 2. So the answer is 2. Okay, and then it says, write down the equation of the line in the form y equal to mx plus c. So we've just worked out the gradient, so it's definitely 2x. The c value is where it crosses the y-axis, which is 4. Okay, that's your gradient. And this is your y-intercept. Part B, without drawing, show that the line 2y equal to 5x minus 3 is parallel to the other line, okay? Now, to test for parallel lines, they need the same gradient. Okay, that's the test. So, line 1, 2y is 5x minus 3. Because I want it in the form y equal to, I'm going to divide everything by 2. So I end up with y equal to 2.5x minus 1.5. You can leave it as 3 over 2 if you want, or minus 3 over 2. For the second line, 4y 10x plus 7. To get y on its own, let's divide by 4. So y is 2.5x plus, I leave that 7 over 4. 2.5, because 10 divided by 4. So what you notice is they've got the same m value, so they're definitely parallel. Same gradient. So parallel lines. Okay, so I'm going to go over the questions from 6 onwards, okay? This is a relative frequency table, and it's to do with testing a total of 1,000, 2,000, 3,000, 4,000, and 5,000 sockets, okay? So when they ask you how many of the first 3,000 were defective, if you look at the 3,000, okay, it's midway between 0.04 and 0.06. So the relative frequency is 0.05 times the 3,000, which will be 150. Write down the best estimate for the probability that one socket selected at random will be defective. You must give a reason. Okay, when you're looking at a frequency table, relative frequency graph, you need the most number of trials for reliability. So it's definitely because there are more trials. Okay, we're using the 5,000, but the probability, if you trace from that cross back, you end up in one small square less than 0.05. Okay, so if you think of that as 0.050, it'll be 0.048. Okay. Factorize and hence solve. Okay, so when you're factorizing, you need numbers that add to make -2 and multiply to make -24. So if I look at factors of 24, without looking at the signs yet, 1, 24, 2, 12, 3, 8, 4, 6, then 4 minus 6 is going to be the 1, which when you add, 4 minus 6 is -2. And when you multiply them, you get -24. So that tells you the two brackets, x plus 4, x minus 6. Okay? But it then says, and hence solve. So basically, if you make that into x plus 4, x minus 6 equal to 0, because you're replacing that with the two factors that you've just worked out. Okay, now for this to be solved, either x plus 4 is 0 or x minus 6 is 0. Now for this to be equal to 0, take 4 away on both sides, and x will be -4. You've got to get x on its own. To get x on its own, add 6 to both sides. So x will be 6. Solve this equation. Okay, it's quite a complex equation because you've got algebraic fractions. Okay, now if I've got in the denominator 2's and 6's, I can multiply everything through by 6. Okay, I'm looking for the lowest common multiplier of 2 and 6. Okay, if you like, this is the thinking behind it. So if you look at your times 2 tables, 2, 4, 6, your times 6 tables, 6. So this is why we're going to multiply everything through by 6. So I'm just going to rewrite down what we've got. 4x minus 3 over 2 plus 7x plus 1 over 6 equal to 29 over 2. So I'm going to multiply everything through by 6. Okay. And the reason we can do that is because how many 2's are in 6 is 3. The 6 with the 6 will cancel out, and the 2 into the 6 is 3. So what are we left with? We're left with 3 lots of this. Be careful of that. It's 3 times all of it. So it's 12x minus 9. If you do 3 times 4x, 3 times 3. Then in the middle, we've just got 7x plus 1. And that's equal to 29 times 3, which is 87. So you're making it into a linear equation. The 12x and the 7x, 19x. Minus 9 plus 1 is minus 8. And that's equal to 87. So I'm trying to solve it to find x. I'm going to add 8 on both sides. So 19x is 95. To get x on its own, I'm going to divide by 19. So x is 5, which is the correct answer. So there's lots of different steps in that. I think it's well worth the 4 marks. Okay, question A. This is an enlargement, but it's a negative scale factor of -2. And there's a centre of enlargement, -2, 1. So the first thing you should do is to plot the centre of enlargement. So -2, 1 is there. Okay, it's up to you if you want to label it centre of enlargement, as long as you know where it is. So let's have a look at how we do a negative scale factor enlargement. If we look at this original shape, I'm going to label it A, B, C. Okay, so how do I get from the centre of enlargement to A? Okay, so to A, I've got to go 1, 2, 3 across, 2 down, which is 3 minus 2. How do I get from the centre of enlargement to B? I've got to go 1, 2, 3, 4, 5, 1, 2, 3, 4. So that would be 5 minus 4. How do I get to C? I'd have to go 1, 2, 3, 1, 2, 3, 4, 5. So that would be 3 minus 5. Okay, so that's from the centre of enlargement to the original shape. And because it's scale factor -2, you've got to times all of these by -2. And I'll show you how to do that. Okay, 3 times, so each number, so 3 times -2 is -6. -2 times -2 is +4. 5 times -2 is -10. -4 times -2 is 8. 3 times -2 is -6. -5 times -2 is +10. Okay, now for the purposes of showing you how to do it, I'm going to keep with the same pen colour, but I'm still working from my centre of enlargement. So I've got to do -6, 4. 1, 2, 3, 4, 5, 6. 4 up, 1, 2, 3, 4. So that must be A dashed, okay? Because it was the one related to A. For B dashed, I've got to do -10, 8. So back to the centre of enlargement. 2, 4, 6, 8, 10. 2, 4, 6, 8. That's going to be my B dashed. And if you want to, you can join those up. You can join those up first, okay? You get the idea. And then for C, -6, 10. So from the centre of enlargement, 2, 4, 6, 2, 4, 6, 8, 10. That's my C dash there. Okay, so that's my final enlargement with scale factor -2, and the important part is that centre of enlargement. Okay. Question 9. A rectangle measures 38 centimetres. So the length 38 centimetres, width 26 centimetres. But they've all been measured to the nearest centimetre. So that means to the nearest 1 centimetre. Now for your lower bound, okay, so for the lower length, you would do 38 minus half a centimetre. And for the lower width, you would do 26 minus half a centimetre. So that would be 37.5, and that would be 25.5. And why have I picked out the lower length and width? It's because they want the least possible area. So the least possible area is the lower length times the lower width, because we're thinking length times width. So 37.5 times 25.5. And the answer is 956.25 centimetres squared. Okay.